Hi guys, this is Mr. Gagnon again. We're going to take a peek at Newton's second law. And Newton's second law is a bit more complicated, but at the same time, it's pretty easy to understand once you learn a little bit about the math behind it. So Newton's said, well, as his first law said that inertia, said that things tend to stay in motion or at rest until something stops them. So Newton's second law talks about the dynamics of that. So Newton said that if you have a force, which we're going to define as a push or a pull, force we can say is equivalent to the mass of an object and its acceleration. Okay, so force is equivalent to the mass of an object times its acceleration. Okay, so let's just take a look at this in a real-life situation. When I was younger, I used to watch it was a strongman competition where there was a guy guy or girl, actually. In some cases, the girl would do a lot better than the guy in some of these because they usually have more leg strength. But in any case, there was a guy or a girl that would try to apply a force to a huge mass, and to create an acceleration, a movement in the object. So what they would do is they would, this was the most interesting one, they would take and tie a big rope around the front of a train that was on a track. And it was a train, but it didn't have any of the boxcars attached to it. It was just the first part of the train, the engine. So what they would do is they took a rope, they attached it to this massive object, and it was a train, and they took the rope in their teeth, actually, and they had to pull the train with a force to try to get it to accelerate with their teeth. So they had to grab onto it with their teeth and pull it. And that was cool. That was interesting because it was like, wow, this is something else. These guys are pulling these trains with their teeth, and they had to get the max acceleration. So the biggest acceleration would win. Some of the cases, the train would not move at all. Obviously, you're going to be pretty strong and pretty powerful to be able to do that. So with Newton's second law, we apply a very small force, we'll say, from the strongman, onto a very large mass, like a train. The acceleration is going to be small. So if we look at it in terms of like the size of the letters, so if we put a relatively small force on a very large mass, then we're going to get a very small acceleration. Okay. Now, if we take the same size f and we apply it to a bit of a smaller mass, that acceleration actually has to linearly get larger, okay, like this. And then if we apply the same force and we shrink the mass down to a tiny little, teeny, weeny little mass, the acceleration has to make up for it. So now in real life, this makes sense because if I apply a force to a large mass, I get a little acceleration. If I apply a force to a medium-sized mass, I get a medium-sized acceleration. If I apply the same force to a tiny little mass, I get a large acceleration. Okay, this could be an example, could be pushing a train. Okay, an example of this could be pushing a wheelbarrow. Okay, an example of this could be, now a very tiny mass and a very large acceleration could be shooting a pellet from a pellet gun. You get a regular force, tiny mass, and a large acceleration. So I hope this helps you kind of understand a little bit about Newton's second law. We do have some math to go along with this. But conceptually, this is a good way to kind of understand what happens there. Okay, we'll stop there.